Yeah. It's a wonderful day here in Seychelles. It's a Sunday morning. Today is the 23rd of April 2003. I'm your host, Erias Kasule. Today we are going to discuss our topic of simultaneous equations. And by the time you leave today, I expect you to understand what we mean by simultaneous equations and the methods which you use to solve simultaneous equations. I expect that by now you have the prerequisite knowledge of transforming equations, normally or usually what you call making the subject of the formula, or transforming an equation. So with that, I'll introduce you to simultaneous equations. Usually an equation should be having variables, and when we say that they are simultaneous, then you have more than one equation to be solved. So for us to be able to solve any simultaneous equations, the number of equations must be equal or more than the number of variables. We are normally used to x, y, z. So if I'm going to solve simultaneous equations which have two variables, let me say x and y, I need at least two equations to do that. Now, what methods do we use to solve simultaneous equations? There are four methods. I'll write them down. The methods. I'll write them down very fast. We have what we call the substitution method. We have what we call the elimination method. We have what we call the graphical method. Here you solve using graphs. You've drawn maybe equations of straight lines or graphs of straight lines, so you can solve them using that. We also have the matrix method. However, for our syllabus of IGCSE, we shall focus on those three methods: the substitution, the elimination, and the graphical method. So I'll start with the substitution method. So basically you can try to understand in the perspective of English what the word substitution means. To substitute means you are going to remove and then put something else. For example, if it is football, one player will have to come out of the field, then another player will be substituted in the place of that player who was moved out. So basically this is how the substitution method works. So I'm going to just take one example very fast. I think I'll use my book here, favorite one I'm using these days for the Cambridge IGCSE Maths students book. Simultaneous equations is on page 222. You can call it 222. Yes. There, simultaneous equations. So I'll just pick only one example, then we shall try to solve through using the simultaneous equations. Well, let me choose this. It's on page 226, and the question I'll choose is 13J, exercise 13J. The question is 5x. I have another board here. Let me just write it here. It is 5x plus 2y equal to 13, and we have x plus 2y equals 9. So basically these are my equations, so I could call this equation 1 and this equation 2. So these are simultaneous equations. You can see there are two equations and we have two variables. What are the variables? The variables are x and y. And these numbers which appear before those variables, we call them coefficients. We call them coefficients. So now, in the substitution method, usually look forward to getting those equations which have a coefficient of 1. It is better you make that the subject. For example, when I observe this is coefficient 5, coefficient 2, coefficient 1 is here. It is better I make this the subject of this equation. So from equation 2, our x is equal to, take the 2y the other side, 9 minus 2y. So why we choose one with the coefficient 1? It makes you avoid fractions at the first stage of your first steps. So now it is this x that is going to substitute, as we already said the word substitution, that is going to substitute into the first equation. If I had used the first equation to make it a subject, then I would substitute into the second equation. So this x, we are putting it into our first equation. So what is it going to be? Okay, let's go. So put x there. It's going to be 5. Let me write it with black. As it was, 5. Where there is x now, put this, which is being substituted. So I'll put it there, which is open bracket, 9 minus 2y. That is the substitute, plus 2y is equal to 13. So, open up brackets, 5 times 9 is 45. 5 times minus 2 is minus 10y, plus 2y equals 13. So, 45, I can bring 13, but I'll have 45 minus this gives us 8y is equal to 13. Now to avoid the negative, dealing with the negative, I can take this 8y because it's negative on the other side and I bring the 13 this way. So 45 subtract of 13 would give us 8y. Okay, so subtract 13 from this. What does it give us? I think it gives us 32 is equal to 8y. So we divide by 8, we divide by 8, and you can see that our y is equal to 4. Having got y as 4, then I come back, I put it back here to get my x, and my x will now be, let me use the blue for you to see the x. Our x will now be the 9, 2 times 4 is 8, which makes x to be equal to 1. Then you conclude that therefore this is a mathematical symbol, x is equal to 1 and y is equal to 4. So that is the substitution method. We shall be going over more examples and then handling other methods for solving our simultaneous equations next time. Thank you very much for now. See you in the next lesson.